Welcome to February 10th LeetCode Challenge. Clear digits. You're given a string S. Your task is to remove all digits by doing this operation repeatedly. The operation is delete the first digit and the closest non-digit character to its left. Return the resulting string after removing all digits. So say example number 1, we have ABC, the string ABC. We return back the same thing because there are no digits in the string. Let's use example number 2. We have CB43. If we delete all the digits, and then delete the closest non-digit to its left, the first time we do this would be B3, and the last one would be C4, and then we return an empty string as such. So the constraints are that the length of S is between 1 to 10. 1 to 100, I should say, and S consists of only lower case English letters and digits. The input is generated such that it is possible to delete all the digits. Alright then, let's go about doing that. So we're given the string S containing only letters and digits. Our task is to perform the following operations with every digit. Remove the digits, and then if there exists any non-digit characters to its left, remove that as well. So as we edit, some ideas would be if we iterate through these and apply this operation, so we will end up with removing all digits of non-digit characters as well. And then we'll return a final string after the process of removing all the digits. So one way would be doing a brute force. So basically iterate through using a while loop, I should say. And then you just delete the characters. If you find delete the number, and then you find a character to its left. However, let's just go about doing using a stack-like operation. So say say if we were to instead modify the input, we construct an answer from scratch as we iterate through the characters of S. So say if we have a character of encounter a non-digit character, we want it in the end of the answer as it will appear in the final string, unless there's a digit that later removes it. So meaning that if we encounter a digit and we do not add it to the final answer, we remove it from the last character from the answer if it exists. So therefore, the main let's just go about doing it actually. So first thing I'm going to do is initialize results. Let's say if we have a string builder, call it results, or the answer, I just call it answer. And that's going to be a new string builder. Initialize that. So initialize an answer to an empty string. Next we want to do is iterate through S with each character index from 0 to the length of S minus 1. Let's go about doing that. I'm just write down some comments. Iterate over each character in the input string. By doing that, we're going to use it. Let's do a for loop. So for int, let's call it character index equal to 0. Our incrementing, I guess, dictator would be when the character of index is less than the string length of string S. All right, and that's going to increment by the character index plus 1 plus. All right, now let's say if the current character is a digit, then what we want to do is add it to our add to the length of basically our stack. So let's say if we have a character, say checks if it's a digit, so we use the character library. Character is digit, and we say S character at the index, so that'll be char index, and the length of our answer is not equal to 0. Dot length. is not equal to 0. If that happens, what's going on? Oh, if this is a character right there, whoops. Then what we want to do is, if the answer string is not empty, remove the last character. And to do that, we do answer dot set length, and we're gonna basically answer dot length -1. All right, let's do that. Else, oh, I should probably do the else here. Else if the character is not a digit, add it to the answer. So it'll be answer dot append, and this could be the character of S at the character index we're at, iterating through. All right, and with that, we exit this for loop, and then we should be able to return our answer to string, because that's the string we're looking for. Let's run this and see how it goes. Oh, of course, string builder. Looks okay. Let's submit. So initially you can see right away that it's big O of n for time complexity, because we iterated through all the characters in S to perform a constant time operation, including the check, and either removing the last character of the answer string or adding it to the character that we're returning. So therefore the total time complexity is big O of n, so linear time. Space complexity is also big O of, interesting. So big O of n, I should say, because string builder, string builder simulates a stack, so therefore the structures are either neither part of the input operation or the output algorithm, so they may contribute to extra time complexity. But let's just call it big O of n, as these structures can grow to the most of the size of the string, input string. All right, that's it. Have a great day.